Now that we've looked at the properties of rational functions, we want to be able to draw rational functions by hand by looking at the different characteristics. So let's start out with a very basic rational function, 1 over x plus 3. And specific characteristics we like to look at include the vertical asymptote, horizontal asymptote, slant asymptote, holes, intercepts, and the domain of the function. So I just want to start by going through each one of those and seeing, do they exist? And if they exist, what are they? And then we'll begin putting together a picture of the graph. So let's start with vertical asymptote. We know a vertical asymptote occurs when we get a 0 in the denominator and the factors do not cancel. So you can see right here my factor in the denominator is x plus 3, which means that x cannot equal a negative 3. Now there's nothing in the numerator for that to cancel with, so that means x equals negative 3 is going to be one of my vertical asymptotes. Second thing I look at are horizontal asymptotes. Remember, there's a couple of criteria that we have for horizontal asymptotes. If the degree of the numerator is larger than the degree of the denominator, then we have no horizontal asymptote, like x to the 6th over x cubed. There's no horizontal asymptote there. The second condition would be if the degree of the numerator and denominator are the same, such as x to the 4th plus 6 over x to the 9th plus 8. I take that back. X to the 4th over 6 plus x to the 4th plus 9. With those, both of those are x to the 4ths, and we take the coefficients that are in front of those x to the 4ths, which would be 1 over 1, which in that case would be 1. The final case is what I was stating originally, when the degree of the denominator is larger than the degree of the numerator. And that's the case that we have right here. The degree of our numerator is 0, the degree of our denominator is 1. So the degree of the denominator is larger, which means my horizontal asymptote is going to be y equals 0. Now, a slant asymptote occurs when the degree of the numerator is exactly 1 more than the degree of the denominator. And you can see right here, if the degree of the denominator is larger, well then I can't have a slant asymptote. Slant asymptotes only occur when the degree of the numerator is exactly 1 larger than the degree of the denominator. Next thing we look at are holes. And holes occur when you've got factors that do cancel. Now up here we only had the one factor, the x plus 3. It did not cancel, so that was a vertical asymptote. So we're going to have no holes as well. If I did have a hole, what I would do is I would figure out what value makes the hole for the x coordinate. I would then cancel out the factor that has the hole, or that created the hole, and then I would plug that x value back into whatever is remaining in the function. The next are the intercepts, both the x-intercepts and the y-intercepts. Let's start with the y-intercept. The y-intercept occurs when x is equal to 0. So we want it to be 0 comma something. So if we know our x is 0, we plug in 0 for x, which is then 1 over 3, which is 1/3. If we find our x-intercepts, those need to be in the format where it's something comma 0. We want to know where it's going to cross the x-axis. So it's got a height of 0 on the y-coordinate. So for this, if we have y is equal to 1 over x plus 3, and we're setting y equal to 0, and I solve it out, you can see when I multiply both sides by 0 here, this x plus 3 to the 0 side, I get 0 equals 1, which isn't a true statement. So the x-intercepts don't exist. So there are no x-intercepts. And then finally the domain. We have to exclude negative 3. So we go from negative infinity to negative 3, and we union that with negative 3 to infinity. So now I've got all the characteristics of this rational function, and we can begin plotting those values out. So first thing is vertical asymptote at x is equal to negative 3. Draw a nice vertical line here, dotted, indicating it's an asymptote. So vertical asymptote at x is equal to negative 3. We know we've got a horizontal asymptote at y equals 0. No slant asymptotes, no holes. We know we've got a y-intercept at 0 and 1/3, so if that's 1, 1/3 would be about right there, 0, 1/3. And I've almost got a complete picture here for what this graph should look like. I know that my asymptotes are going to be guidelines. And if I've got a point here which I know to be defined on my rational function, I know my graph is going to come down along one asymptote and then go along the other asymptote. The question is, on the other side, what is it going to be? I don't know, is my curve going to be up here coming down and around or down here and coming around? So we want to do just a quick little check to see what that would be. Our graph is not going to cross over our asymptotes for the most part. They never cross vertical. Sometimes you can cross a horizontal, but for basic rational functions, if we know a point is defined up here, the whole graph is going to be up here, or if a point is defined down here, the whole graph is going to be beneath the horizontal asymptote. So if we just choose a value that is to the left of -3, so let's say let x equal -4, so then I have 1 over -4 plus 3, which is 1 over -1, which is -1. I know the point -4, -1 has to be on the graph. So -4 and -1 would put me over here, which means that my graph is going to follow along the curve like so. If I want to confirm on my calculator, I can do that. Going to my y1 and then plugging in 1 divided by x plus 3, hitting graph, and I can see there's a quick sketch of what my rational function looks like. Got my vertical asymptote right there, horizontal right along the x-axis.